Good. All right, so my name is Paul Long. I'm a senior PM, and I work with Message Analyzer. So how many people have used Message Analyzer in this room? Okay. Have you downloaded the latest version from Connect already? Okay, well, that's one of the first things we're going to go over. But first, I'm going to give some background into what Message Analyzer is and what PEP is. So how many people have used, like, Network Monitor before in the room? All right. Wireshark? Okay, so now we're on the same path here. Message Analyzer is kind of like Wireshark, kind of like Netmon, but a lot different. So that's what we're going to talk about. So kind of go back into the history of things. We basically had a compliance effort to document all our protocols. And from this, we learned a lot about how to design and how to write the documentation. So in the past, what we had was sort of an exploratory archaeology type project. And we had the protocol design, and they would create the code, and then we'd create the technical document. And basically what happens, we had this mess of artifacts. So what we wanted to do is kind of centralize the protocol development around one specification. And so the specification for, I don't know why Carl is showing up on my thing here. I don't even know how to get rid of it. I'll close it. The specification is written in something called OPN, which is kind of central. It stands for the Open Protocol Notation. So we have this central idea. We take OPN, and then from the single definition, we can derive all these other artifacts. So we could derive things like the source code description, or the skeleton, the framework, and then we can add the source code. We can create documentation frameworks, so our developers don't have to write documentation anymore, at least not all the boring stuff. They just fill it in with the important stuff. And then the part that we're kind of going to talk about today is the network analysis part. So Message Analyzer can take the OPN and use that to decode it, decode the binary bits that flow across the wire, so you can understand the protocols. So that's just some of the history. And so Message Analyzer is this little circle down here. There's other things like test suites and other pieces that OPN helps us do. So let's talk about differences, because I think one of the first things that someone that uses Message Analyzer, that used to Network Monitor or Wireshark, sees a completely different view of things, and they get confused. And I can understand you get confused, but what we're trying to do is show the information that's important from an application view. And I think for people doing file sharing, plugin, dealing with those protocols, or with Office protocols, that's really what they want to focus on. But I think people that use Wireshark, that's kind of, they show you the network view of things, and then you kind of have to bubble up, and we kind of do it the other way around. We also simulate the protocol behavior. So not only does OPN describe the structure of a protocol, it describes some of the behavior as well. What protocols it sits on, what it expects in terms of requests and responses. The example I give is like S&B has this idea that it negotiates tokens, not tokens, I forgot the name now, but it basically negotiates this value that lets it keep track of how many outstanding operations it has. And you negotiate this at the beginning. You might say I have 10, and then you go over that amount. Well, we can actually look for that protocol behavior violation and show that in the UI automatically. So we do some simulation, which kind of means that we might be slower in some cases. Now, we're not that slow. I mean, one of the primary complaints we've had with Message Analyzer is that the performance is not as fast as Wireshark and Netmon. In a way, it never will be, because we're doing a lot more. We've actually improved the performance a lot in the latest version, so you should start seeing performance kind of as good or better than Netmon was in those days. But we do more things, so there's always going to be a little bit more overhead. We also coalesce the information automatically. So with Netmon, if you wanted to look at fragmented data, you actually had to hit a button and then cause it to open up another window that would put all the pieces together. Wireshark does some of this at the TCP layer for you automatically. But with Message Analyzer, we coalesce everything as much as we can all the way up to the upper layer. So what you end up seeing, and I'm going to go over this in some more detail, is only the top layer, the SMB message. And we go beyond that, actually. We say that if you have a request and response, well, don't show those two messages separately. Let's actually combine it into one and just make one descriptive line of what's going on. And then if you have to drill in and you need to see some the interaction between two messages, you can turn all these things off, which I'll show you in a second. Another advantage of this is that by putting requests and responses together, we can do some analysis for you in terms of performance. So we can detect for you the server response time, which I'm going to go over also in detail in a second. But that's another thing that we do automatically. So now I'm going to go through a series of slides that are around this crazy-looking graph. And so to set it up, the area in the black is probably something that you might see in a protocol analyzer. So I have a timestamp on the side. I have them set in these rows or columns, or I don't know, going backwards, are all in the same conversation. So this is all one conversation, this is all another one, and then the first row happens at the same time at the 1 second mark, second row happens at the same time, and so on. So this is just to illustrate what you see in the various protocol analyzers, so you kind of get an idea of what we've done differently. And so the messages on the left are what you'd see, and you start off with a TLS message, then a response, an ARP, an SMB. So this is what you would see listed in your protocol analyzer. So this makes sense. Any questions? Because the next 4 or 5 slides just deal with this beginning picture. So let's kind of just get a frame of reference. So what Wireshark does is it does some reassembly for you automatically, but it doesn't hide any of the messages from you. In fact, what it does is it takes the last fragment, the last one, and reassembles the data on that last fragment. So you see in Wireshark a bunch of fragments, then the last fragment won't be there. It'll be the upper level message. So you still see in the display in Wireshark 16 different lines. You still see everything there. It doesn't hide. There's no messages disappearing. It's also noisier, which is the thing we wanted to get rid of with Message Analyzer. So in Netmon, oops. Oh, and this was the network monitor view, by the way. So this first slide, the first fragment is the SMB, but there might be other fragments that just look like TCP, but the first fragment doesn't get totally parsed by default. So in Wireshark, the last fragment gets reassembled in some cases, not all cases. And in fact, with SMB, there's lots of cases where it doesn't happen properly with Wireshark. And then in Netmon, we have this button that allows you to reassemble the data. So in that case, we actually add in some extra, these black ones. So we actually add in more stuff and more frames that you have to look at, which is, I think, maybe confusing as well. And so a Message Analyzer, we try to coalesce this data for you. So what we've done is for the SMB request and read, well, first of all, you can see up the stack that we automatically reassemble this data for you. And that at the top, you just see these single messages. So each bar at the top represents a single message. So if you go over the list in the black, we still see the TLS messages. We haven't, reassembled those because they're encrypted. But we have this, the next message is an HTTP operation. Because we put together the request and the response into one message. So therefore, we've gotten rid of all the fragments that were in the original list, and we've hidden them, and the request and response we've also hidden. So now we have this single operation that tells you what's going on, and the cool thing is we can measure the lengths of these bars. And by measuring them, we can tell how long it took for the operation to occur. So you'll see in a second when I do one of these demos how that's really useful. So we take the 16 messages, because it's a 4x4 grid, and now we have a lot fewer messages. In fact, a lot of it's just noise that I could probably pretty easily filter out. If I looked at just SMB, there'd only be one message that I have to look at. So again, it's a simple way to get rid of the noise. So I can hide operations. Those things where we put the request and response together is called an operation. We can do this for more than just a request and response. For instance, for LDAP, all the related search entries could go into one operations. So it could represent many messages, but most of them are request response. So in that case, if I hide those operations, well, that top bar goes away, and now we see the request and response. And this might be useful if you want to see how two different request and response interact with each other, because the operations will sort of hide that since we group it. So this is with turning operations on, which is a button you'll find in the UI. So now, some people have the question, well, I want to see the TCP. I want to find out what's happening at the network layer. For some reason, I'm interested in seeing the actual interaction at that layer. And I think if you're doing this, you're troubleshooting a network issue probably, not your protocol. So we have this feature called viewpoints. And I think it's kind of a confusing thing because people don't understand what's happening. So I tried to make a picture of what happens. And so a viewpoint slices across the plane. It makes everything above it disappear. So once I turn this viewpoint on, I now see this. And the other thing actually it does is it also filters out anything that's not part of the viewpoint. So this viewpoint's defined as TCP. That's all the viewpoint is. It says protocol TCP. So it says, all right, anything that's not TCP, get rid of it. And now only show me the TCP fragments and all the TCP fragments. And so these viewpoints can be defined. We have a bunch of them built in. You can define them yourself. You have to do some special configuration. But the hope is that we have the ones you need in box. And if you don't, give us the feedback and we'll add some. They're pretty easy to add yourself as well. So another example, or actually a comparison. So what if you did a filter? Why can't I just filter on TCP? Wouldn't that do the same thing? Well, actually it doesn't, because when we filter on TCP, we look in the stack, the black boxes here, and we say, is TCP there? We'll include the message. But we still go up to the top and say, OK, well, I'm going to go ahead and coalesce the messages, all the operations. And if you filter on TCP, you actually only see these, and this is not formatted, but the 5 lines there, basically. It looks like 6, but there's a new line in there. So filtering on TCP works, but it doesn't only show the TCP messages. It still parses up to the top. And we call this the top. When we have the top-level parser, or top-level protocol, that's what we're just talking about. And so here's another example of a viewpoint. So I created a viewpoint, and this one doesn't exist, but called HTTP and SMB. It looks for both those protocols. So viewpoints can be defined however you want to. But all this really says is that, all right, slice off everything on the top. Well, this is the top. SMB and HTTP are the top in this example. Now you could have RPC on SMB, could have SOAP on HTTP. All those layers would disappear. So if you wanted to focus on the HTTP layer, a viewpoint's one way to do it. And so I just took the plane off the top and then got rid of all the other messages, because again, it filters out anything that's not SMB and HTTP. And I only get, and again, it didn't format properly. But basically, there's 2 messages: the top bar, the SMB read, and HTTP operation. So this major difference in Message Analyzer results in fewer messages in the view. You open up a trace, could have thousands of fragments because you did 4 SMB reads of some huge file. But in Message Analyzer, you might only see the 2 or 3 reads that exist. So it takes all that data, combines it, makes it disappear, and now you get to see the top layer and hopefully focus on the layer that's more interesting to you. Again, you can configure it with viewpoints to see the other layers if you're interested, but that's not the default view. So I think the problem you might see is you go into Wireshark and say, I'm looking for this message, but it's not over here in Message Analyzer. Well, first of all, you have to understand Wireshark does something weird by taking the last fragment and making it the SMB message. So you might see message 10 in Wireshark be the SMB message, but that's actually the last fragment. And 10 is not it's actually a bunch of fragments that make up that message. So you have to kind of understand how Wireshark works, how Message Analyzer works in order to do a comparison. Any questions on that? OK, so all this intro is just to kind of give you an idea of why Message Analyzer is different, how it's different. Another thing that people ask, or they'll come and say, well, I loaded up this trace and it took a long time. I'm just not going to use it again. Well, one thing that Message Analyzer does is we cache protocols as we load them. So the first time you ever open a capture, it will be slower. or can be slower. We try to precompile a lot of these things, but we don't precompile every single protocol. So you might touch one that we haven't encountered before. It'll just take a little bit longer that first time to come up. But after that, I promise you, it's faster. And in some cases, a lot faster. So since we do this defragmentation and collation of the information, that means that when you type a filter like IP address equals something, there's fewer upper level frames that you have to touch. We don't have to go dig into every one to see the IP address is the same, because we know the first one's the same, the last one's going to be the same if it's all into the same tree. So for cases like that, it's actually a lot faster to filter once we load all the data up. So let's go into the three things I think you do with a protocol analyzer. And the first one's new, not something you do with Wireshark or Netmon, and that's sharing. And this is the ability to share assets that you create. So for instance, you have some cool filter that you use with your team all the time. The sharing infrastructure is a way to share these assets that you use to troubleshoot your protocols with your team, in the future with anybody in the public, or even by email, saving out the asset and sending it to somebody. So there's lots of these things that constitute assets, like charts, like viewpoints, like filters, color filters. So all these things can be shared, and I'll point out some of them to you. Another thing you do is you capture your data, right? You go out, and I've got to start a trace. I'm going to reproduce a problem. I'm going to get the information. So that's another thing we're going to review, because I think it's important. And then finally, you want to analyze that data. So we're not going to go over like how to analyze specifically an issue, but we'll talk about the different analysis tools within Message Analyzer that let you do your job. So let's talk about sharing. And I think the main thing for you guys is the parser. So we've developed the parsers. They're in the install. When you install from Connect, you get all the built-in parsers. But in order to get the Office parsers, you have to do something special. And the idea is that once you download the Office parsers and we do an update, we can push them to you automatically. And that's something that we'll enable as we move forward. So the way this works is when you start Message Analyzer, you go to the start page. It has some, and this is not where it starts. It always starts on the news. And so the idea is we'll push out an update. And you'll get a news item up here and say, hey, there's new parsers for Office that have been updated. If you've already synchronized the Office parsers, you'll get them automatically. But if you've not synchronized to them, you can either synchronize, or maybe there'll be some news item up there that says, hey, there's a new parser, or we've done new things. We'll advertise that there. When you go to the download section, you get a list of all the parser packages and potentially other packages that can be synchronized from feeds. Right now, I'm not synchronized with any feeds. I'll show you that in a second. But the ones that are important to you guys, what you want to do when you run Message Analyzer is go here, if you're interested in the Office parsers, is Exchange and Active Sync 102. So if you click, you have an option to download them once or automatically download them and keep them in sync, which is what I would do probably. Now again, the first time you open up our Office parser, we're going to have to compile all these and cache them, so it'll be slow the first time, but after that it should be faster. And so you do these for these three, the Office ones, the Office and SharePoint, and then there's a third in this list. Now there's other ones in the list that you don't have to worry about. We have some updates to do to make this a little bit more friendlier, but the last one is the Exchange Web Services. And so now I should get any updates we push out, any bugs, fixes in the parsers, you'll get automatically, and you don't have to worry about those, at least moving forward. This is a new, the infrastructure is kind of new, so this is going to be the first time we're using it to push out updates. So we'll see how that goes. So the last thing I was going to show you with feeds is this idea that I could subscribe to a feed. So you're already subscribed to one feed. This is our feed for our assets that we ship in the product. So we can update them out of, you don't have to install a new version of Message Analyzer necessarily to get some new filters that we've updated. So that's already done for you automatically. But I'm going to attach to a feed, and what I'm going to show you first is what the feed looks like. And so it's really just an SMB share in the simplest form. It can be this Azure feed that we use for our assets, but that's not something that we've told you how to do. So the limitation right now is that it's a file share. And in this file share is just a bunch of assets that have gone into the product and say, save that filter, save those. And then I copy the file to this SMB share, and I've added it. Now, if you're interested in doing this, if you think that you have an interest in doing feeds, contact me. It's easy to share the first time, but there's some tricks you have to do. But once I do this, and I just give it some name, now I can go into the downloads, and now I'll see all these other assets in blue. And you can see that when I click on Paul's feed, it shows me only the ones that are specific to my to that feed. And so I could go through and do them all. Like, for instance, I like my local loop back, and I would do them all. But this is the one I'm kind of interested in, SMB, because I'm going to do a demo on that. And so I can also share charts, a lot of other things. But this is one way to attach the feed. Now that I've attached to this feed, it'll synchronize when I make a change to the server. And now I'll have new assets available to me in the UI, which you'll see when I go through the other demos. And so this is a slide, and I'll update the slide so you can look at it rather than memorizing what it said. But these were the Exchange ones that you need to update. And that was subscribing the feeds. And this is an example. Now that I have this feed, I'll have new items appear in the filter list. Or this was actually how to share them. I'm not going to go over that right now. Okay, and the last thing is that if you can mark things as favorites. All these feeds have an idea of being a favorite. And when it's a favorite, it flows up to the top. Because once you get a lot of these filters, for instance, maybe you have a few favorites that you want to do. In particular, with the trace scenarios, and trace scenarios are basically a way of collecting the data automatically, which I'll show you in a sec. But you can make those favorites so they show up in the quick access bar. And that's the next thing I'm going to go over. So before we go into capturing, any questions on shares and feeds and parsers? Yes?
I tried one of the text log parser, the .config file.
Okay.
And it's pretty sparse on documentation. Just kind of copy and pasting from the existing
Yeah.
and Samba
Sure.
log. Is there any better sort of description of how to create those types of parsers?
There isn't, so I want to create a blog on that because I think there needs to be one. So we do have, so what he's talking about is that you're able to import any kind of log file. If you have some text log file that you use and you want to integrate it with the data, and I'll show a demo on this in a second, you can integrate, you can parse the data, put structure around it with these config files, and then allow you to view them in the analyzer, do all the filtering, color filtering, charts that you want to do, and then you can put them together. So the config files are written, it's all OPN. Everything's OPN. It's just a weird looking version of OPN. So there's an OPN guide on the Connect site, and that's where you'll find information. Unfortunately, the guide's a reference guide and not a like how to do this guide. So it's kind of confusing. But what if you look at, the regex statements are just regular regex statements. And there's a site I use, Dirk Slagler. I'm not going to do a demo on this, but you can type in a regex and then put some code and figure. So that's what I use to debug, and that's how you do the regex statements. And then the format of the like what you can put in the message part, that's all in the OPN reference. It's just not very straightforward. So unfortunately, I don't have a great answer for you. It's not the easiest thing to do. Feel free to ask questions on the forum. In fact, you might have already, or certain fields have.
It seemed like I read the OPN guide. It seemed like it wasn't documenting well sort of the libraries that are available. It documents the language, but not the libraries of classes that are available to use in the parser.
That's a good question. I have to look to see if there are. Because I know there are certain libraries we expose, and I have the same problem. I don't know it very well either, so I have to look. I look in the OPN parsers because it's the same thing. So if you can find an example in a parser, an OPN parser, you can use that in a config file as well. So for instance, if you wanted to use some kind of string manipulation, you can look to see. And I think we've exposed certain ones, and not like the whole library, but I'll have to see if we have a reference. And if not, hopefully we'll have more documentation. I think your best solution is just ask on the forums, and we'll go dig it. And that's how I'll learn what people want to know, and then we'll document it based on that. Cool. Any other questions? All right, so capturing data. So I think the first thing is we've changed our UI a lot since the original version, especially in terms of capturing and opening files. So I want to go over this a little bit. In fact, let's go to the UI. So we no longer have a backstage, we just have a menu. And if you just want to get up and going and get a quick trace, just start, and we have 3, and these are favorites, by the way. I've marked these 3 are favorites by default. If you mark other ones as favorites, they'll show up there. The top one, and we're going to rename these, by the way. We understand they're not the greatest names, but the top one is how you do a regular trace like you would with Netmon or Wireshark. It's just an endless level capture. You click it, and it goes. It'll start capturing right away. The next one's kind of interesting because it allows you to do 2 things. One, well, more than 2, but 3 things. Allows you to capture loopback traffic. So if you have an IIS server and a SQL server on the same machine, that traffic used to be invisible to you. When you have 2 servers of the same machine that talk over the network, it talks over loopback, and Wireshark and Netmon do not see it. The firewall inserts itself in the firewall stack and captures higher up. So it captures before it reaches the NIC and allows you to see that traffic. The caveat here, and this is another thing I hope to fix in the next iteration, is that you have to configure the firewall, because the way it works is it captures outgoing traffic and incoming traffic, which results in duplicate traffic for the loopback data. So if you want to capture just loopback, you have to configure it to capture just loopback. And if you want to know, you can ask on the forums, or hopefully, again, we'll fix this moving forward, but it's not too difficult. And then if you want to capture, the other thing it does is allow to capture encrypted traffic over IPsec. So IPsec traffic gets encrypted at the IP level, but firewall captures above that. So you can capture unencrypted IPsec traffic. Again, the loopback traffic kind of clouds it because it looks like a lot of retransmits since there's duplicate data. And so all you do is you say, get rid of 127.0.0. You create a filter, capture filter, and say, get rid of the 127.0.0.1 and the ::1 for IPv6 loopback. And then you'll get a clear picture of that IPsec unencrypted traffic. And then the third thing it allows you to do is capture tunneled traffic. So tunnel traffic, usually gets encrypted. You can't see it on the wire. So if you have a VPN connection and you're trying to capture something, you don't see anything. In fact, you get confused probably because you're like, I did an SMB connection. I don't see any SMB traffic. Well, in that case, you want to use the firewall scenario to capture in the tunnel and then see that data. The third one that's by default is the web proxy, which allows you to capture HTTPS traffic in the clear. Now, it uses Fiddler. Anyone familiar with Fiddler? Okay, so it's basically using the Fiddler API to capture this traffic through something called a proxy. So it sits in the middle, which doesn't work with all websites. And there's certain weird combinations that don't work. I found one person told me that if you use Gmail and Chrome, we can't see it. But if you use IE in Gmail, then you can see it. And I think because Chrome's doing something funny with the proxy. So you'll just have to experiment to see if it works. We are actually trying to implement something within the driver itself to capture this traffic to kind of get around it. But still, the man in the middle might be useful for certain situations. If one of the 3 scenarios aren't there, you can always do the long method. And so the long method involves a bunch of steps. And this is kind of a regression. This iteration, we're kind of marching to a better UI. And so we kind of move some things around to get prepared for that. So excuse us in our internal state. But now what we do is we put up one dialog, and you've got 2 options. You can do a live trace or import a lot of files. So if we do the live trace, then we have, by default, you put a target computer localhost. Now, you can do remote capture as well, which is another thing I'll show you in a second. But for default, we have the localhost machine. And then, again, you have the set of scenarios. So you can see the 3-star ones are the ones that show up in that list. But down below, there's actually many more. And so I think one of the interesting ones are the SMB servers, SMB scenarios. Actually, before I do that, let's show you what a scenario looks like. So we have a scenario that's a remote. Oops, that's not the way. So a scenario just consists of a bunch of providers. And this is like the advanced step. If you want to get into this, this is fine. But what it allows you to do is to capture the network trace, this top line. But you can also capture component level information. So Message Analyzer is just an ETW consumer. ETW is what all our components, well, many of the components in Windows use to like debug statements and stuff for their components. So the TCP component says, okay, I'm going to write some information to use for analysis. They write it in this ETW format. And so Message Analyzer is just a consumer of that format. And so you can collect from a set of providers all at the same time and now do correlation between that. So for instance, you could imagine with the NDIS and the TCP, I could look for a reset and then go to the TCP component at the same time frame and try to understand why it happened, because maybe the reset's not obvious to me. So by collecting at these different providers, you can get more information. Now, I think the hard part for you guys is knowing which providers to include, what the provider's information has in it, how to configure the provider. They're all different. So that's why we built in these trace scenarios so you don't have to think about it. But maybe there's someday you want to collect something extravagant, and you'll probably need help from us, which is fine. So the next set of provider I wanted to go over, because it affects the file sharing part of things, is the SMB provider. So SMB does two things that make it hard to capture. SMB now encrypts data, and it also can be done over a direct DMA type connection. So those become invisible to you over the network layer. So we worked with the file systems team to capture the data at the component level so that we could see it before it got encrypted and before it got sent over the DMA. So we've included these lists of providers, and so what I'll frequently do is I'll just make it a favorite so it shows up in my quick list. But any one of these four can be used to collect the data. Now there's four of them because there's actually five, but the last one's just sort of an extra one. But there's four of them because you can capture from the server side or the client side. You know, on the server, you can look for information from an SMB server, from an SMB client. And then we have two versions of each one, two flavors of the server and the client side. One captures just the header. So if you transfer a huge file across the network and try to capture all the data, you know, not just the header, that means you get all the fragment, the huge file, and it eats up a lot of space in your capture file. So instead, we have a version that captures the header only, which only captures SMB header, lets you troubleshoot that, but then you're missing anything that's in the payload section of the SMB. So two server, client side, and then two flavors of each. And the last one actually just mixes a client with the firewall scenario we spoke of before. If, for instance, you wanted to see encrypted SMB and kind of how it correlated to the on-wire timing, network timing. So now you can correlate the encrypted packets, but with at least some TCP information. For some reason, you want to do like a performance analysis. And there's lots more scenarios. You can look through them. There's some for even non-networking things like Bluetooth and USB. So you can troubleshoot a lot more than just networking issues, which is, by the way, why we didn't call it Network Monitor 4, because we felt like there was a shift, enough of a shift that we're focusing on any kind of messages. And like we talked about with the config files, that could be text logs from your adapters, and that's one of the examples I'm going to show you in a sec. I say in a second, it's probably not a second, but I have a 5-year-old, and a second is really a second to him. He complains when it doesn't come as quickly as he wants. So this was the UI, and these are just all for your reference. We're not going to go over the slides. The last one I wanted to call out is we do have a PowerShell interface. So if you wanted to automate a capture and say, I've got some test running, every time the test's running, I want to start a trace and then stop it under some conditions, PowerShell is what you want to use for that. And I have a blog, Message Analyzer blog. If you just look up Message Analyzer, the blog should be one of the first things you find. There's a specific blog on PowerShell which you should read before doing it, because PowerShell is not the most, I don't know that it's not user-friendly, but it's a different kind of system. But there's various commandlets that allow us to automate the capture and trigger on special things, like when an event is hit or when a certain piece of traffic is occurring. Oops, this page is mistitled. It should be called Analysis. Oh, yeah, analysis. So we're just going to go over some of these topics, and most of them will be demonstrations. But this is about analyzing the data, not capturing. I want to analyze the data. I've got it all. I've got all this data sitting on my drive. I want to figure out what kind of things I can do with Message Analyzer. So the first thing was this importing, and let's do this example actually. So I do File, New Session, and it presents me the dialog to choose which I want. And so I hit Files, and now I'm able to import a lot of files. And so you can drag and drop in here, or you can hit the Add File button. And in this case, and this is an example I've done before, but now I have a twist, another twist here that I'm going to add. So in this case, I have a PCAP trace. So we can load in PCAP and the PCAP Next Gen. We support all of those. But we also support the Samba syslog in particular that's created for, for file sharing. So I've added these two pieces of data. And one thing that's changed in this version is now you have to specify the type of log file. So it's kind of cool we auto-detected it, but one of the side effects of this is that in order to auto-detect, it caused a performance issue. So we'll probably revisit that, but now you have to specify which log. It actually becomes difficult if you're creating your own config log. You sometimes find that it parses the wrong thing in the old version, so this kind of at least lets you pick what you want it to be. Now, the other thing about importing information that's useful is that sometimes you get lots of data, right? Someone gives you a gig trace that's run for the last 2 days, and now you got to analyze that. So you open up Message Analyzer, and you're waiting and waiting and waiting. Well, if you know the time period where the problem occurs, you can narrow that down. Now, sometimes that requires you type it in manually. Like PCAP doesn't really give us any details about the start and the end that we can use. So but you can manually type the time, and the time is the specific format. But like, for instance, if you open an ETL, I don't want to do that now. It'll give you an example, and then you can click on the checkbox, type in the start and stop time, and now you have less data import. It takes less time because we just quickly scan on the timestamp and then import that data. I actually had someone using it the other day. They had a 1.8 gig trace, but the customer told them, or actually there's an event log in the cluster log that said, hey, it went down here. And so they were just kind of narrow it down to 5 minutes, load it up quickly, and analyze the data. But I'm not going to do that. So now I've entered this line. I could actually add other lines of files with different timelines if I wanted to. I can also specify how to open it. So it's by default is the analysis grid. And then another new feature, which I didn't even put in the slides, is we have this parsing level. So another idea we had is that you load up a trace and it tries to parse everything, and that takes a long time. Well, now we allow you, again, we kind of include these things, and I think they're duplicated because I've loaded up a lot of internal builds, but there's only half this list is there. By selecting one of these, we only parse up to a certain level, and we restrict parsing of other things so that you can sort of tailor your parsing experience to increase the speed at which it loads and potentially the speed at which it filters as well. So if you're only interested in network analysis, you could stay at that network analysis layer. Now, it doesn't let you see like if it's an SMB message because it doesn't parse all the way up to the top, but it's a performance thing. If that's what you're interested in, you can configure it. For now, I'm going to leave it as full. And so now it's imported the data pretty quickly. And I'm going to close down Column Chooser. And so here is the network data. And if I go down a little bit, you can see that these system Samba syslog data is intermixed in between. You can see like there's a UDP message right in the middle. So it's interlaced the messages by timestamp. So this is done by default. When we import the data, we try to line it up by timestamp because we figure that's the first correlation element that you'll use to figure out if data goes together. Now there is a case where the log file will have a different time zone than the captured data. This trace happened to be made in Washington, so it lines up. But whenever I do this demo back in North Carolina, where I'm from, by the way, it isn't lined up, and I have to do something special. And so what I can do is there's this feature called shift time, and I can choose to shift the log by fractions of a second in case they're just a little bit off, because I don't know, maybe the log is a little bit behind, or by hours to correct for time zones. Now this is probably a feature that we want to move to a different part of the UI to make it easier, but this is a workaround for dealing with the time shifts due to time zones. But again, I don't have to do that since we're in Washington. So then the next step here is that in order to correlate these, I can correlate them by time. So I'm going to create a filter. I'm going to right-click on Samba syslog and say Add to Filter. We try to make filtering easy by clicking on different parts of the element, on different parts of the UI. We also have IntelliSense, so if I don't know what it is, I can start typing, and I want to do S&B, so I can use the autocomplete feature to figure those out. By the way, when you're typing a filter, you'll see this big dialog box sometimes appear over here, and usually don't have time to read it all. What that means is the filter you typed in is not going to be the fastest filter in the world. You should make it more specific. But the convenience factor is maybe you don't care for speed, and you just want to type in something like star address or star name. You know, maybe you know there's a field called name somewhere. You don't care where it is. You can use star in your filters to find those. If you do know where it is, then probably use a fully qualified path, snb.name. So I can apply the filter, just sort of narrow it down to those two pieces of data. And so now what I want to do is in the SMB message. So by the way, we have this encoding here that shows these colored icons. The green and the blue are the two that we have. If it's blue, it's this operation I told you about before. So this is a SMB message that consists of, and if I break it open, you see a request and a response underneath. So I'm going to show you another thing that for me is useful, especially since I deal with so many different domains. I like putting in a control. So this tools window has a bunch of interesting different controls, and some of them are on by default. So the one I like is message stack, and it puts it as a tab here at the bottom. I'm just going to move it over. And what this shows me is the full message stack. So when I click on this message, it gives me this tree. But actually, I like this one here because it's a visual. And there's a bug. I have to click on it again. So it kind of gives me this visual of what the layout. And so now you can see that I have an operation. And underneath it are two SMB messages. And underneath it, it actually has some reassembled packets that it put together for me. And so you can kind of give it a visual of what the full stack looks like. And that's what we hide from you, by the way. You don't get to see all these fragments and stuff. We've hid that for you. So you just see the SMB request and response. So the reason I did this, and by the way, you can click on here, and it'll drive the details, is because I wanted to add in the command. And I'm going to add it in as a column for this demo. So great, I now see the command for the first SMB messages, but also in these log files, there's also a command buried somewhere in here, and I often have to click around to find one. Bear with me for half a second while I... There. But they call it something different. They call it SMB underscore com, and we call it command, so it's two different names. So we've created a feature to group these together, and we call it union. And so basically a union is taking fields with different names and giving it one common name. And so I'm going to actually have to do this, so I'm going to call it SMB command. I can give it a category. And now I can add them in here. So I know one's called SMB, and I like using the search at the top of the field chooser. So I'll add this one. The other one is going to be harder to find, I know, because it's SMB. No. So we'll do SNB. Oh, that's right. It doesn't matter which command you add, I'm pretty sure. So now that I've added this union, you can see it listed here as SMB command. There's now this new part of column chooser called unions. And hopefully, now you can see that I now have one column that represents both. And you can see that it has 50 where it exists for the text log. And so now this allows me to have a single column. Then we have this feature called grouping, which I'll show you in a little bit more detail. But by grouping on this, by the way, I can right-click in column chooser and group, which I couldn't do before, new feature. By grouping, I now grouped all the commands together that are the same. So now I can look at all the 50s and see the text log and compare it to the network traffic at the same time. So this union feature allows you to kind of do a correlation between data values that are named differently. Any questions on that? All right. So let's see. So let's talk about grouping. Let's do it in the perspective of a remote capture. So I'll try to do this real quick. So remote capture allows me to collect from multiple machines at the same time. So in this case, I'm going to capture from a machine here in Washington and then my desktop back in North Carolina. So I'm going to capture from two remote machines at the same time. I'm going to select a, You can do any scenario you want against them, but the ones that I want to show you are, there's one called remote link layer, which adds the remote network provider. And then you can configure this. And the reason you might want to configure it is because in this case, Apex 03 is a Hyper-V server with lots of NICs and lots of things going on. But I just want to connect to one virtual machine running on that box. So it gives me a list of the switches. I can check, and box needs to be bigger. So I could say, okay, I just want to connect from the interfaces on the machine itself. But I could connect to any VM. The VM could be running Unix or whatever. So if you have a Hyper-V server, this is a very simple way, and you can do this locally as well. This is not limited to remote, but this gives you the ability to configure that remote. Now the other thing here is that we only capture the first 128 bytes. We don't want to weigh your network down with a bunch of sending the data over that just went to the machine. So we try to limit that for you, though you can change it if you want the full header. And there's other configure options. For instance, you could limit it to an IP address, a MAC address, a specific port. And by the way, I can configure both machines in there. That was one machine. The other machine is just a desktop, so only has interfaces, not Hyper-V, so there's only one interface there. And then I could start the capture. So now it's going to go to each of those machines, start the capture, and send the data back to me. So the one machine in North Carolina, the one machine in Washington, collecting all that data in the same place. So I want to see which machine came from which machine. Which data came from which machine. So I'm going to group by data source. And when I do that, it now grouping collates the two pieces of information and says, okay, the top one's Apex 03, the bottom one's WAM 07. So now I can see the data coming from one machine versus the other. So now another way, and this grouping, by the way, is, right now I'm grouping to understand the network topology. You could group to figure out, group by file name to figure out what files were being affected. There's lots of power here in this grouping feature. So I'm going to add this network. A network is the group that allows you to see, that puts the pairs together for network source and destination. So now I've grouped on those. And then finally, I'll group on transport, which is the same thing but for TCP and UDP connections. And it's going to freeze on me. And so the idea here is that I'll have a display of the transport, a organization of the data that lets me see endpoint traffic by machine, network, IP address, and then the transport, TCP transport. So when this gets, I have to go find the one that's called transport, which is arguably not the best experience. Or if I knew where it was. I tell you what, I know it's under TCP, so I'll just go look there. So I can add this as a group. And now if I break open one of these, and I'll look for something with IP, you can see here, let me stop the trace so it doesn't jump around. Like here's one that shows between these two IP addresses, there's 5 or 6 UDP connections, and it shows the port. So now I've kind of organized this data in a way that I can troubleshoot it to figure out, just this traffic is dealing with this single conversation from this one machine. Now you can move these around. I could move the data source on this side. Now I want to see the same data from those two different perspectives. So it kind of allows you to pivot on different things as well. So I think with grouping and union, there's this powerful correlation idea that now you can take your data from all these different sources and combine them and analyze them together. So any question on grouping or unions? No? So another important one, and this is kind of really important for you guys. Probably should lead it off with this. So like I said, the OPN analyzes the protocol behavior as well. And in fact, we built in some of the rules into the OPN so that if your protocol does not meet the standards that were written, it'll signal you. So one part of your job has been simplified greatly. If you've written an implementation that has, that's missed some must equal 0 and doing a negotiate, message analyzer will point those out automatically. So we do that with this diagnostic column. So I could group on those. Why not? And I could say, all right, well, now I'm interested in these ones. Look, the AND X response message is not decoded completely because the command value in the last X-min is not set to FF. So somebody didn't follow one of the rules in the documentation, and this was exposed through message analyzer as one of these diagnostics. So all I did was click on the icon to see the message. There's also another window called the diagnostic window, which basically shows all the messages in one window. Now, I'm going to give you a little bit of warning. This window has some performance issues sometimes. If you have a lot of error messages and you see the UI going slow, try closing this window down. It's some issue that we have to resolve yet. Actually, I'm not sure why it's not showing them right now, but it should be. I don't know. So I talked about viewpoints at the beginning just to show you where it is in the UI. So we'll just take this trace. So in the UI, we have viewpoints. We can reset the default viewpoint, and I can hide operations. So let's look at, I think looks like there's some data in here that's SMB. Oh, it's this trace. And so I could turn off these operations, hide operations, and now you see all the requests and responses separate. So they kind of go in a row, but if they didn't go in a row, the operations might have obscured something that was happening. So that's how you turn off the operations. And then you can set a viewpoint. For instance, if I only wanted to analyze the SMB viewpoint, now all the RPC or anything that's sitting on top of SMB would go away, and now I could just focus on the SMB messages. Hey, Daryl, how much time do I have? Is this 11 or 11 something? 11:30? Okay, cool. So let me show you something more about viewpoints. So the thing with viewpoints is that when I change, in fact, let's set the viewpoint to something else, to TCP. And I have to remove my filter, which is part of this demonstration, is that now the summary's gone away. I can't tell that they're SMB messages anymore. I just see the TCP messages. So I've changed my viewpoint to TCP, which, by the way, is in the, it shows you down here, which probably no one's ever looked at this part here, but we do have a status bar that has some interesting information in it. And the problem is that maybe you want to see what the SMB message or what the top level message is. So we have columns for those. oops. And so we have top-level module and top-level summary that will show me what the top level is along with all the fragments. And you'll see that in some cases, let's see. That's not a good case. In some cases, since it's multiple fragments, they'll have the same top-level summary. So you'll have, for instance, in a file read, I've flummoxed. The demo gods have arrived. Come on. If that doesn't come back, I'll just start a new. Oh, there it came back. Thought it came back. If you have your viewpoint set to TCP and there's like 7 fragments, you'll see that the top level summary has the same description for all those fragments, because in the end that fragment is related to the same top level entry. So by adding these columns, it kind of gives you the best of both worlds in that you can see what the top level is, but you can still see what the fragments are. Now, I can save these. So let's say that I was interested in keeping this the same all the time. So let's see if it works this time, and it will. So now you can see I have the top level and the TCP fragments. Let's say I really want it this way, maybe. And say I wanted to group by module, because grouping by module is a very simple way when you start off with a trace to figure out what's in it. In fact, it's one of the first steps I always do when I have a new trace. Now, I've set the viewpoint to TCP, so the only module that's going to show there is the TCP, but I could group instead by the top module. And now I could say, okay, well, now I want to dig into the SMB2. I still see all the TCP, but now I see the top module's SMB, and I can get a summary. I'm sorry, the top module summary is what happens to it when it gets parsed all the way. And then, for instance, I can see that this is all the same summary from here. Oh, now he comes back. From here to here is the top summary, but it actually represents different fragments of the same message. So this is a way to set the viewpoint, but still reference the top-level message when you change the viewpoint. Does that make sense? Okay, let's see what else we're going to talk about. All right, sequence matching. So this is something, it's a very interesting feature, very powerful for normal analysis. And the idea here is that when you create a filter, everyone knows that a filter allows you to look for a single message that matches some pattern. So I want to find all the TCP messages that have this same port value. That's what a filter does. The sequence expression is a filter that you can do between multiple messages. So you can define a sequence expression that says, when I find a port in this message, find 4 more messages afterwards with the same port, but with some other message, some other field set to something different. So let's take an example, and I know my example's broke, but I'm going to do it anyways. So in this example, our users have asked us to identify a specific problem. And the problem is that sometimes an RPC connection is created, but it negotiates a port via the endpoint mapper. But the port it negotiates is blocked by the firewall. And this is difficult for them to find because they don't really have, they can find the block, but then they got to go find the endpoint. So we can create a sequence expression to look for this pattern. So we're going to do some kind of on the fly here. So let me open the trace. It has this traffic in it. And so a sequence expression is defined again with OPN, and we don't have a special part of the documentation that tells you how to write sequence expressions, but we've included 2 within the package. But I like this one because this is just, the 2 that are included are fairly simple, and this one's a little bit more complex. So the way you, well actually let me make sure that I have this sequence expression, because this is one that I include in my download. So I have one called, let's see, RPC sequences, so let me synchronize that one. So the way you run a sequence expression is you create a new view. And new views are all the same. You right-click, or all the same, access the same way. You right-click from Session Explorer, you say New Viewer, and then you get a list. Now in this case, I have the common ones, which includes the sequence expression, plus some others that we'll go over in a second with charts, and some that I've included from feeds. So just kind of point out the feeds, you can see that my items are all the ones in the machine. Message Analyzer are all the ones for the Message Analyzer feed. And then Paul's feed are some charts that I've included from my own feed that hopefully I'll get in the box in the next version. In fact, I should be able to do that. But I'm going to open a sequence expression window. So it opens up another window. I like to put them side by side. What did I do? I opened 2 sequence expression windows. And so now the idea is that once you click on the window, you'll see the sequence expression drop down come up. So it's not there because we put tools that are specific to the visualizer at the end, to the ribbon. So when we go here, I now have a sequence expression. And now I can choose which sequence expressions I want to look at. So let's do that, and I think this is not going to work. Yeah, I know. Yeah, I was hoping I could fix this one, but I can't. All right, well, let's do this. So the way you create a sequence expression, or one way to create one, is you can start off by clicking some messages. So let's say I want those 2 messages. In fact, if I was really going to do this, I was going to do the endpoint mapper. And so you can say add to sequence expression. And so we have this UI that allows you to kind of create sequence expressions, but it has limited flexibility or limited abilities. But I could do this to kind of get an idea of how it works. So I could say, all right, well, I'm kind of interested, I know in the map tower, I don't remember where it is now. I'm not daring to, I'll tell you what. And then in this one, I'm interested in, I don't know, is big Indian. And I can do that for all of these. And then I can create a simple sequence expression that looks for values across multiple messages. So you can think for some simple scenarios, this is a way to create the sequence expression. But as with anything else, sometimes you want to get more complex. So you can switch to freeform, which then allows you to type in basically OPN in here. But it gives you an idea of how to access the messages and how to create the sequence expression. So in this case, it's very much like regex in how the sequence expressions work. We create this scenario we call sequence expression, which can have any name. And then we look for a value. And this is the message name. So if I go up here, oh, shoot. I should have added the type. Maybe I better do it again. So I can add in type as a column. So for things like SMB and and other higher level application level protocols, the type will tell you, for instance, which SMB command it's using. In this case, for RPC, there's different commands within RPC, so the type is the different type of message that it represents. And the reason that's important for this example is because when you write the sequence expressions, it includes that type as part of the reference. So I'll just do this again with one of them. Oops. And so it's looking for a type called ETP map, which maps the column name type, and saying, I want the inner value equal, and then following it, doesn't have to be immediately following with this particular syntax. There's the next message, and then somewhere down the line there's another message, and you can set for the same values. So that's something very simple, a simple set of sequence expressions. But now we're going to just take a minute to look at this one that doesn't work, only because it has an interesting... And the reason it doesn't work is we've fixed RPC. We used to not parse the endpoint mapper completely, and so I had to reference values by their offsets in a blob of data. So now we fixed all that, but I didn't update my sequence expression. Actually, I did, but not on this machine. But just to give you an idea, so I have comments here, and I'll try to space out the comments so you can just sort of see what happens. So this says, all right, find me an endpoint map message response. The forward slashes say it's a top-level message. If you don't put the forward slashes there, it says go look anywhere, but this says it needs to be at the top level. Just makes it work faster. And then I do some memorization. X1 and X2 now contain some values from the tower offset. So like I said, we don't parse it, or we didn't parse it before, but I knew that the port combination was at 2 offsets within this blob of data. So I've memorized those in X1 and X2. Then I look for a TCP segment where the destination port is a word that combines those 2 values. So I've memorized some values from a previous line in the trace, and now I'm going to use them to look for a destination port, a 3-way handshake basically, where this destination port matches this. And then I look for traffic going the other direction from the source port, but I also want it to have either reset or 2 SYNs, because I know that that's the behavior I see when a firewall blocks a port. Either it doesn't respond at all, and I get multiple SYNs, or it resets the connection. So this will detect when we have an endpoint mapper set up a port, and then a firewall detects it. And so when I run the sequence expression, and I won't run this one, but I'll run a different one just so you can see how it works. I think these will detect something. And these are the ones that are built in. So we look for 3-way transmit pairs. And so for each of the ones I check, which by the way, you can check a whole group of them. So for instance, you could have, I want to find these 20 different kind of patterns. It'll go through and look for them. And then the results for each type of pattern shows up here. So I have 3 3-way handshakes. I can select each one, and then on the left side, I don't know why it should highlight the messages. Oh, because I filtered out again. Sorry. All right, so now when I select them, it highlights the 3 messages that it's found on the left side. So actually, I'm just going to do one more example to drive through something, because this is I have a file sharing one that I think is a little bit more, which is a different example, which even shows more flexibility. So let me go to the start. Start page, downloads, and I have, is it that one? I think that's the example. I'll try it. I don't have it. Well, I'll just talk about the other. So the other example, just to give you an idea of what it can do, is I created an example to look for a SMB file open, and then any number of reads and writes, and a close. And it found each one of those as a match as a sequence expression. So I had to memorize the SMB session, the file, the tree connection, and then grouped all those together. So sequence expressions is very powerful. It's something that, I don't know for you guys how useful it'll be, but if you have problems you come across all the time, if you have sequence or set of messages that indicate some issue that you want to find easily, this is a very powerful tool for that. So any question on sequence expressions? And yeah?
I guess just a little more general, Paul. It seems like you've got an inline editor there for your sequence expression, hit save, applies it.
Yeah.
If you're doing parser work, what's the best write, test, debug cycle? Do you have to restart the...
Yeah, so it's kind of, so the question is that if you're doing OPN or sequence expression development, what are the best tools to use? And so we don't really have a good development story. We haven't focused on the development story, to be honest with you. We think it's a smaller group of people, but obviously there are people interested in it. What I use is, I use Notepad++ actually, because I don't think we distribute it, but at least internally we have a colorizer for it. Or Visual Studio is another, we have a plugin, but we haven't made it external yet. So that's the plan, the route we want to go. What I have to do is just like what you have to do is I write in the text log configuration file, I open up Message Analyzer, load it, I see errors. The trick is if you get errors, you don't have to close Message Analyzer again. So with text log file, at least that's a little tip. But yeah, if it works, then if I change it, you have to shut down Message Analyzer and restart it to get the changes. For sequence expressions, I use the sequence expression editor has a validate, and so I use that to validate and get the results. It's not an ideal thing. It's one of the things I complain about all the time because I do it a lot, but I think it's probably a smaller majority right now, but something we'll focus on later.
No CLI tools to at least validate your syntax?
No, not that I'm aware of. I think you probably could. We do have a command line. I thought we distribute the command line compiler. I don't know if it's there. I've never tried it before, so maybe there's some option that you can compile and get some errors, but I don't know. I could look into it and maybe write a blog at some point. Any other questions? All right. So that's sequence expressions. So charts. So I think the idea behind charts was to be able to visualize problems quickly and drill down into them. And the problem is that somebody has to create the charts. And we knew that there weren't going to be, again, a ton of people creating charts. And our team has been working on some charts ourselves, and I'm going to show you one that we'll be distributing hopefully in the next version. But there is a chart editor built in. So I'm going to use this example of an SMB trace. Make sure I remove the default viewpoint. And so in this SMB trace, the user was comparing performance. They had a good trace and a bad trace. And so what they were interested in is a top-level view of the messages and how many messages were sent from the SMB point of view. So we're going to go ahead and create a quick chart, a simple one, and then I'm going to show you the more complex one. Just to kind of show you, I don't think maybe this is something you won't do very often, and it actually is not the cleanest UI because it wasn't a high priority in terms of users, but I did want to have something that you guys could mess with, and I think once you learn how to create one chart, it kind of translates a little bit. So the way I got here, by the way, whoops. Oh, no. Yeah. So if you don't want to save. You go to Chart menu, New Chart, and it creates this blank chart. Now the problem with blank things is that you often don't know what to do. So the first tip I'd say is that if you want to figure out how charts work, is use one of the built-in ones. So we have Protocol Dashboard, which is one. And when Protocol Dashboard comes up, you can edit it. And actually, you can edit it live. It'll update the data. And at least this is one way you can learn. So the way it works is you can click on any of these areas, and sometimes you have to click in the right place. And when you do, it updates the data based on what you click. And there's 3 different tabs at the top. Chart layout defines, and let's go to our blank one. Chart layout defines how many rows and grids there are. Right now there's just 1, but if you wanted 2 side-by-side charts, well, you could say I want to add in another row. And there's different things you can do with the how they line up, the column width, and all these things, but don't worry about that. So now I have 2 sections. You see the dotted line on each side. So let's go ahead and add a component. When I add a component, I have different choices, especially where it goes, which is kind of important. And so for this one, I'm just going to leave it in the first row and column, which is 0, 0. And so now I have actually by default it creates a component, so I just created 2 components, by the way. But when I click on here, I have some other choices. I can give it a name. My SMB chart. And then I can also associate some data with it. And this is the trick with charts, is associating the data. So the first thing I'm going to do is I'm going to add in, I've got to do this slow, I suppose. So when you click on the fields, there's dots next to it. And they're hard to find. If you don't know they're there, you probably never find them. But once you click on a line, you can hit the dot, and now you can add in fields. So I'm going to add in some row fields. You can add rows and columns for any kind of chart. So I'm going to add in, and I can use the dot, or you could just type in. I'm going to add in the type. So again, the type for SMB, as you'll see in a second, is the type of SMB command. So hopefully, yeah. So now you can see it started populating my chart. And the reason there's 2 of them there because let me actually do this because it'll get confused. Okay. So now I have the type, but you can see that it's more than just SMB data. So I want to filter it down. Well, you can type in a filter in a chart just like anywhere else. I can't remember what kind of data it is. So now hopefully that chart will be specific to the SMB or SMB2 data. And you'll have to excuse me because I did this on the wrong one. I wanted this one. So go back here. Row. This time I'm just going to type it in so I know its name. I don't have to go through the column chooser. So now it should be applying a filter on the data that will narrow down the rows to just the SMB portion. So the next thing I want to do is add in a column for each row. What do I want to add up? So I'm going to add up how many times each message occurs. It's funny, I did this morning and it also took a long time, so I think I'm discovering a bug. I know it will come back. And so once I create the second column, or the way I'm going to create the second column is it's going to be a formula. So I can there's a bunch of built-in formulas. There's stuff like count, the count of how many messages, the average, the minimum, the maximum. You can divide 2 columns or 2 fields. So rather than waste a lot of time, maybe I'll just show you the end result since I have this other instance up. So I've created this one called SMB service response time. And so this is the same information I put in here. Let's go edit it just so you can see. So I've created again, the row field was type. But what I did is I created this calls. So I added a formula. I went here and said add formula. I gave it a name called calls. I gave it a formula type. So here are the different ones you can do. You can do a difference. You can add them all together. You can divide. You can do an average, a count, max, and min. And then in the arguments, in this case, for the count, I just did message number. I want to count every type. And I just say message number because it's one of the fields that's common in all these types. And so when I do that, it creates this chart. And I've done other examples. So the calls was my count. It says I have 1,798 reads. Okay, my whole trace is basically reads. But I was also able to do some cool stuff like say, well, I can take a maximum and minimum server response time. So I didn't show you this yet, but it's a good time. With SMB traffic, or with any kind of traffic where we do operations, here, we have this time elapsed column. We also have a column that we don't add by default called response time. So let's add that in. So these two things give you information about the performance of SMB, or anything that has a request and response. The time elapsed measures how long it takes to send the first message to the very last message. So if you have a file transfer, or let's just say a single read, SMB read, and I say read this data, and it sends me back the data, well, I'm measuring to the last message in that data. This is kind of a calculation of how fast your network and system and service is running together. It's measuring both those things together. Response time is a little bit different. Response time is only measuring the difference between the last request to the server to the first response. So this is how fast your server is responding, the service, whatever it is. So now I can put these two values together and say, well, if the time elapsed is a lot greater than the response time, then I know that the network is slowing things down. In fact, I can sort on this data, by the way. So I could say, all right, let me sort and see the biggest ones at the top. OK, I have some 2-second ones. In fact, I have some 2-second ones with some diagnosis. There's a granted number of credits issue. I don't know if that's what they all say. If time elapsed is a lot greater than the response time, then the network is potentially slowing you down. It's something to do with transferring that packet, the set of data. Yeah, exactly. It's the total time. There's some bottleneck that's not the service response. Maybe it's a better way to put it. I think that time elapsed represents anything to get the data. So it could be the network. It could be the hard drive, like you said. It could be the service just trying to get, maybe it's locked. Maybe the file's locked or something. So, but the service, the response time is measuring how fast to get that first message. Now, maybe it takes a while to get the first message too. I don't know. But in a lot of cases, these two values are used. You know, this is service, SRT. This is just a common metric that people use to measure service request response. So that's what we're exposing in these two values. And then in my chart, I use those values to generate. I use the min function to say, well, get me the minimum time and the maximum time and the average time. And then using this chart between two different traces, they had a good trace and a bad trace, they're able to tell that one machine was a lot slower and that it was the network that was causing the issue. And in fact, it was kind of really easy because in Message Analyzer, we have the diagnosis whenever you have a TCP retransmits. So they're able to see the SMB message, click the diagnosis, and it says that there's 100 retransmits or whatever. So it's kind of, it almost makes the hard problem really simple when you look at it that way. But with this chart, you can get a high-level view of the service response time for SMB, and it's only limited to SMB because I filtered that way. So for instance, it's filtered on SMB2, but if I wanted the service response time for HTTP, there's no reason I can't just change the way the filter works. Because it's very generic. It's always based on the operation. So any questions on that? It's sort of like a fast how to create a chart. Yeah. Yeah, so you can, so I just showed a simple chart. You can say, change it into a bar chart. And so you can specify a bar chart and then have the y-axis be time. And in fact, there's also not a bar chart, but a line chart. so we don't have a histogram, but we have a line chart, and this requires time as a second factor. I don't think I can do it real quick, but Protocol Dashboard, for instance, does this. So yes, you can do it, but it's a line chart that would have time over response time or something like that. And that's what this bottom top chart kind of shows you, is an example of protocol module over time by density. So this just shows you the spikes. These little purple spikes must be ARP spikes that happened at certain times in the trace. Okay, this is, maybe it shouldn't have been last, but it's a really cool feature. So decryption, we talked about this, I think, in these types of conferences a lot, and this is a very interesting topic for folks. So we now have the ability to decrypt traffic. So we can capture it unencrypted, but what if you got a trace that's already encrypted and you want to encrypt it after the fact? So we've now built in this capability in the message analyzer. And so with my last 5 minutes, which is now 4 minutes, I'll do this, new session. Kind of did it the long way. Okay, so actually before I do that, you basically have to set up Message Analyzer to say which certificates you're going to use. So now under the File menu, under Options, there's this section at the bottom which allows me to input certificates. So I could add in a bunch of certificates. It has to be the private server-side cert. Well, if the client could do it, then anyone could decode the traffic. So this is the way security works. But if you have the client-side cert, which you can export from Cert Manager as a PFX, you can add the certificate. So that's all I did here was add the certificate. I gave it a password, my very strong password of 1 letter. And now when you open the trace, let's open it now. We will attempt to decrypt the traffic based on that cert. So another window you want to add when you're doing this, and also a window that certainly affects performance, is once you open the decryption window, we'll now search through the whole trace, which affects the performance. But we search through the whole trace to find which connections, and by the way, you can always rip any of these boxes out and put them on a different monitor or whatever, shows me what it tried to decrypt. So it says here that this line was decrypted. I can actually click on it again, and it drives the selection in my grid. So I've now clicked on that message. I can see, well, actually it has some retransmits associated with it. But when I click on the stack, you can see here in my stack view that it was based on a TLS message, a TCP message, a TLS message that then we decrypted using a decryption expert and now has HTTP on top. So it's decrypted that message based on the search I provided. So this gives you a way to very simply in the trace, and you can save it out as well. And so the customer could do this potentially if they don't want to send you the private cert, and then send you a trace that you can then read unencrypted. So I know that wasn't a deep talk about how it works, but it's pretty simple. You just add in the certs and then open the trace. Yes?
So that works for TLS. Does that also work with Kerberos and KeyTab and your channel?
It works with certain things, and we're extending it right now. The question is, does it work with key tabs and other certificate types, I guess you're talking about, right? Or are you talking about different
Other protocols.
Yes. So, yes. Right. I think we're working. I have to actually check. I don't know. And maybe someone remembers back there. But I know that we were working on extending what it works over. And I think RDP, I think it either does work or it's going to work. And there's some other. UDP was another one that we're working on that's not done yet. But yeah, there has certain limitations right now. And it's really just a parser change, I think, for the most part. There's some complications, but we'll extend it pretty quickly, I think. All right, yeah.
What are the best methods to capture traffic from non-Microsoft or non-Windows machines, like going to investigate
Yeah, so to get a trace, you'll have to use something like Wireshark, or I don't know if Mac has a built-in utility. We don't have any way of tracing that data, but if it's, as long as it saves a PCAP, we can read it, we can load it.
Can I use it like in reverse proxy or to a man-in-the-middle attack like Fiddler?
Only if Mac supports Fiddler. The Fiddler tool is like a Windows-specific version of Fiddler.
But I can still use Fiddler on a Mac if I just configure the Mac network layer to connect to my Windows machine as a proxy server.
If it's the client, the Fiddler only works as a client-side proxy. So if you want to capture it unencrypted, you have to do it from the client side with Fiddler. So if Macintosh has a Fiddler client, even if it does, I don't think Fiddler lets you save anything.
You can configure Fiddler to accept traffic from other machines. So Fiddler does not need to run on the same machine. On a Windows machine,
Oh, I see.
external Mac machine.
I
You configure Fiddler to accept traffic from other machines, and you configure your Mac to use your Windows machine
as the proxy.
that sends traffic through your Windows machine.
That's an interesting question. So yeah, the question is, can you, since you with Fiddler you can configure the Mac to use a Windows machine as a proxy? Is there some way to configure Message Analyzer to do that? And I don't know. I guess I have to look. I didn't know you could do that. And I kind of doubt we could do that, but I don't know. All we do is set up the Fiddler proxy. So if you can configure a Macintosh to use that as a proxy, maybe it's just a matter of starting the Fiddler capture, and maybe it'll work. I don't know. I haven't tried it. That's a good question. We can maybe.
Because you mentioned Fiddler, you're using Fiddler modules.
Yeah, I didn't. Yeah, we are. We're just using the API, the latest version of the API. So if it's there's nothing to configure for the Mac side on the, and even if there is, you can bring up the Fiddler UI and still configure it. And I think it's still Message Analyzer uses those configurations. It doesn't know that you've changed them. Maybe it'll work. So I guess you could try it and see. I don't know. I've not tried it. It's a good question. Any other questions about anything we talked about? Have you all used Connect before? Just curious. How many people have used Connect? Okay, if you haven't used it, you have to log on, and you have to join our connection because it hosts a bunch of other connections for other products. So if you don't, you can still get to our site, but you won't see the download. So you just got to remember that. It's 2 steps. You have to sign on to Connect, and then in Connect, you go join different people's connections. You join and you look for Message Analyzer in the title and join our connection, and then you'll see the downloads. And if you have problems, we have forums on MSN. I mean on TechNet. Well, actually MSDN as well. You can ask questions there, and you can also through the blog. You can get my Connect info. If you send me email through the blog, it sends me an email with your email, and then I can respond back directly. That's probably the easiest way to get to me through the Message Analyzer blog.
So there was also one question about decrypting Kerberos related traffic. And I did want to point out we're going to have a test session. Gu Qing here will be presenting regarding testing with Kerberos, including a decryption scenario.
Yeah, so he might know more about which protocols we support right now. All right, anything else? Cool. Thanks, guys.